Welcome to the jankily written regression inference. All right, so first thing I want to point out, this is rarely on the AP exam. It was challenging for me to find example problems for this. So, maybe think about that as we're doing this. But I want to talk about conditions. While we're talking about conditions, I'm going to briefly talk about the hypothesis statements for this, how to read computer output, and what the standard error of the residuals is. I say this is probably the most important thing because I've seen that asked way more than anything else. All right, so the hypothesis statement for a regression test, first of all, is that the slope of the true regression line is equal to 0. The alternate is greater than, not equal to, or less than. What this essentially means is no relationship or no association between the two variables. So the null hypothesis is basically that these two quantitative variables don't have an association. Okay, so now that said, the conditions, they're really hard. I'm not going to lie about it. The acronym that you're going to do is LINER. So linear relationship is the L, I is independent observations, N is normally distributed residuals, the E is equal standard deviation. I really like this word. Homoscedasticity. You don't need to know this, I just think it's fun. Homoscedasticity. And you need randomness. So this is not new, and the independent observations isn't new. That's 10%, and that's the randomness is stated. The other three are a little different. So on this slide, I tell you how to actually check those. So the L, the linear relationship, you get by making a graph of the scatter plot, right? Linearity can be determined as reasonable from the residual plot being random. That's it. So it's awful because you have to make the graph. So this one's a graph. I'm really selling this, right? I'm making it sound really exciting. 10% condition, that's fine. 3, so that one was the normally distributed residuals. So make a histogram of just the residuals and see if they fall approximately in a normal curve. So that's a graph. 4, equal standard deviations. That means you need to make a graph of the residuals to determine if the standard deviations are equal for each x. That's a graph. So actually, those can be one graph though. And then obviously we check the text for randomness. So 2 of the conditions for this are graphs. So that's exciting. No, it's not. All right, computer output. So we've already been looking at these, right? We know that this is the slope, this is the y-intercept. We've looked at the r squared. We haven't looked at anything else. And in fact, we're not going to look at these. We're still not going to look at those. And we're still not going to look at those. The standard error of the coefficient, that's sigma sub beta. This is sigma sub b, beta hat, there. That's that. So like sigma sub x bar is equal to sigma over the square root of n. Sigma sub beta hat, or you could even say sigma sub b sub 1, is equal to that number. That might be useful in confidence intervals. This is your t-score, right? So if you were running the hypothesis test, this is a not equal alternate hypothesis test. They give you the t-score and they give you the p-value. And then they give you this number down here. That number is called the standard error of the residuals. So suppose we use our regression line to estimate a y value, right? Because we do that all the time. The standard error of the residuals is how far we expect to be off when we make estimates. So we anticipate our estimates being off by 1.39959, whatever that is. If we make an estimate, that's how far off we expect to be. That's what that S is. This is important, right? That shows up a lot. The other things show up less often. All right, let's do some problems. As part of a class project at a large university, Amber selected a random sample of 12 students in her major field of study. All students in the sample were asked to report their number of hours spent studying on the final exam and their score on the final exam. A regression analysis on the data produced the following partial computer output. Amber wants to compute a 95% confidence interval for the slope of the least squares regression line in the population of all students in her major field of study. Assuming conditions for inference are satisfied, which gives the margin of error for the confidence interval. Now, these are all the same, so those aren't going to do anything. Nothing new there. All we need to do is put the standard error of the slope. That's this number, which means the answer is A. That's it. Great. Good. Great. Just for reference, I paused the video because I wanted to double check something. These values that I crossed out right here, those are t-stars. And the degrees of freedom in regression is n minus 2. So that's the only weird one. Degrees of freedom for regression is n minus 2. And these are all, like I said, those are t-stars. All right, the residual plots from 5 different least squares regression lines are shown below. Which of the plots provides the strongest evidence that its regression line is an appropriate model and is consistent with assumptions required for inference? So, first of all, I want no distinct pattern in the residual, right? So, A and B are out. So C, D, or E, because there's not like a distinct pattern. However, look at D and E. D, the residuals kind of go inwards, right? So that's that one condition I was talking about. Let me scroll back to it so we can read it together. Equal standard deviation. That's where we make a graph of the residuals, determine if the standard deviations are equal for each of x. So that means the residuals aren't fanning in or out. So the residuals in this graph are fanning in. That is not consistent with assumptions. The residuals in this graph are fanning out. Not consistent. These are nice, random residuals, not fanning, no pattern at all. So the answer would be C on that one. Windmills generate electricity by transferring energy from wind to a turbine. A study was conducted to examine the relationship between wind velocity in miles per hour and electricity production in amperes for one particular windmill. For the windmill, measurements were taken on 25 randomly selected days, and the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. The regression model assumptions were checked and determined to be reasonable. Okay, regression model assumptions were checked and determined to be reasonable. That means we don't have to check any conditions. They did it for us. Over the interval of wind speeds represented in data, which were from 10 miles per hour to 40 miles per hour. Is there statistically convincing evidence that electricity production by the windmill is related to wind velocity? So, is there a relationship between these quantitative variables? So, all the work is done for us, right? We're not checking conditions on this. If we want, though, we could write some hypothesis statements. So let's go ahead and do that. The null hypothesis is that beta 1 equals 0. The alternate is that beta 1 is not equal to 0, because they're just trying to see, is there an association? They're not trying to see if it's a positive one or a negative one. They're just saying, is there an association? Where beta 1 is the slope of the true regression line of wind velocity and versus electricity production. We will conduct a t-test for the slope. Conditions are met because they said so. Okay, I'm going to go to a new slide. Conditions were met. So now I'm in the do step. They did it for me. Look, t-score, p-value. So t equals 12.63. P-value equals 0. Degrees of freedom is n minus 2, which is 23. So I can make my conclusion. At alpha equals 0.05, we reject the null hypothesis. Right? P-value of 0, we're going to reject. There's enough evidence to conclude that electricity production is related to wind velocity. For the windmill. Okay, that's all she wrote. Now again, I want to point out, this is so rarely on the exam. However, you should be aware of it because it could be your year. So don't just brush it off. Make sure that you actually pay attention to this a little bit, take some notes on it, and yeah, bye.